Hello everyone. Today we are excited to present our research and finding on predicting diabetes using machine learning. This project is a part of our business intelligence module at SLTC Faculty of Computer and IT. Our team members are I am W.M.S.H.S.PREMASIRI and R.V.S.P.RAJAPAKSHA, H.E. JAYARATHNA and H.L.V.PRASANJANA. And we have to work extremely to analyze diabetes prediction using machine learning models. Our presentation today will cover the problem statement, dataset, methodology, model selections, evolution, key finding, and future improvements. We will also include a live demonstration of our model in action. Let's get started. Diabetes is the one of most prevalent chronic diseases worldwide, affecting millions of individuals and placing a significant burden on healthcare system. The inability to properly manage insulin productions can lead to severe healthcare complications, including cardiovascular diseases, kidney failure, nerve damage, and even vision impairment. Traditional methods of diagnosis primarily rely on clinical assessments, which, although effective, can be time consuming and expensive, often requiring multiple tests to confirm a diagnosis. However, with the exponential growth of health related data, machine learning provides an innovative approach to enhance early detection and intervention. By leveraging predictive models, we can analyze vast datasets to identify high risk individuals, enabling earlier and more effective preventive measures. Our study explores how machine learning techniques can process and interpret various health indicators such as blood glucose level, BMI, and insulin sensitive, ultimately providing a more efficient data driven approach to diabetes risk assessment and management. The increasing prevalence of diabetes highlight the urgent need for efficient and accurate prediction method. With healthcare system under pressure, leveraging machine learning can aid in diagnosing and managing diabetes for complication arise. Our motivation for this project is to use machine learning to develop an accurate data-driven approach for identify individuals at risk of diabetes. This can assist healthcare providers in taking early preventive measures.
To build our prediction model, we used a diabetes dataset from Kaggle, which contains key health indicators associated with diabetes. These attributes include blood glucose levels, BMI, age, insulin levels, blood pressure, skin thickness, and diabetes predictive function. The dataset provides valuable insights into how these factors correlate with the likelihood of developing diabetes. By analyzing patterns with this data, we can train our machine learning model to recognize high risk individuals. The inclusion of diverse health parameters enhance the model's predictive capability, allowing for a more comprehensive assessment of diabetes risk factors. Furthermore, pre-processing techniques such as normalization and handling of missing values contribute to a more accurate and reliable prediction model. Before training our model, we conducted data pre-processing to enhance the quality and reliability of the dataset. One of the key steps was standardization, ensuring that all numerical features were scaled uniformly. This prevents larger numerical values from dominating smaller ones and improves the stability of the model. Additionally, we handled missing values by using appropriate imputation techniques to avoid data loss and ensure consistency. Furthermore, we performed outlier detection to mitigate the impact of extreme value that could distort the model's learning process. After preparing the dataset, we split it into training and testing sets to evaluate our model's performance, ensuring a balanced distribution of data to improve generalization and preventing overfitting.
Selecting the right model is crucial for achieving high accuracy and reliability in predicting diabetes. We explored multiple classification algorithms and ultimately opted for support vector machine due to its robustness in handling complex datasets with high dimensional spaces. SVM has demonstrated strong performance in distinguishing between diabetic and non-diabetic cases. To further refine our model, we implemented high parameters using grid search CV, systematically testing different kernel functions, regularization parameters, and margin constraint to optimize predictive accuracy. Additionally, we validated the model using cross-validation techniques to ensure its generalizability across diverse datasets. After training our model, we conducted through evaluation using multiple performance metrics to gauge its effectiveness. Our SVA model achieved an accuracy of 78.9% to indicating a reasonable levels of predictive power. To gain deeper insights, we analyzed the confusion matrix which provided detailed information on the number of true positive, true negatives, false positive, and false negatives. This helped us to understand how well the model distinguishing between diabetic and non-diabetic patients. Additionally, we computed the precision recall and F1 score for both classes to evaluate the model balance between sensitivity and specificity. When the model performed well overall, we observed certain areas that require refinement, such as improving recall for diabetic cases to minimize the false negatives and ensuring a more balanced representation of both classes. Although our model performed well, we identify some challenges that need to be addressed for improved accuracy and robustness. Data imbalance in the dataset led to bias prediction, as the model tended to favor the majority class over the minority class. To overcome this, data augmentation techniques such as oversampling the minority class or using synthetic data generation method like synthetic minority oversampling technique could be implemented. Additionally, class weighting technique could help improve the balance in prediction. Another issue encountered was overfitting, where the model performed exceptionally well on training data but struggled to generalization to unseen data. To mitigate this, we could employ advanced regularization techniques such as dropout, L1 or L2 regularization, and early stopping. Expanding the dataset with more diverse data points and incorporating cross-validation method would also enhance the model ability to generalize effectively to new cases.
Okay, thank you, Hansana. Future improvements. Future work should focus on addressing data imbalance through augmentation techniques, exploring additional features and testing alternative models such as logistic regression and random forest could further enhance accuracy. Okay, let's see a live demonstration of our project. Okay, let me quickly walk you through how our machine learning model is performing. First, our model has an accuracy of 78.89%. You can see it here. Here it is. Now, let's take a look at the confusion matrix, which shows how well our model predicted diabetic and non-diabetic cases. It correctly identified 185 non-diabetic patients. It also correctly identified 58 diabetic patients. However, it misclassified 16 diabetic patients as non-diabetic and 49 non-diabetic patients were wrongly classified as diabetic. Next, we have the classification report. Precision measures how accurate our positive predictions are. Recall shows how well the model captures true cases. The F1 score balances precision and recall to provide a single performance metric. Now, let's see the model in action. Imagine we input some real-world data for a patient. Uh, they have had 3 pregnancies. Their glucose level is 140 with a blood pressure of 85. Their skin thickness is 23. and their insulin level is 94. They have a BMI of 28.7 and a diabetes pedigree function of 0.5, and they are 45 years old. We feed this data into a model and here's the result. The patient is predicted to be a non-diabetic based on the analysis. And there you have it, a quick demonstration of how a machine learning model predicts diabetes risks. Conclusion: machine learning holds great potential in predicting diabetes. Our SCM model delivered promising results, and future improvements can make it even more reliable. Thank you for your attention, and we welcome any questions. Thank you.